Okay, good morning, all of you. In last lecture, we have discussed how to find out principal stresses. Okay, so in that, we have discussed how to find out major principal stress and how to find out minor principal stress. After that, next we have discussed that is how to find out principal plane. Okay, so today we will see how to find out maximum shear stress. So please write down next point, maximum shear stress. Next point is maximum shear stress. Maximum shear stress. Maximum shear stress. Tau max. So already you know that. How to find out tau max? Tau max, which is equal to tau max, which is equal to major principal stress. Major principal stress. Major principal stress minus minor principal stress, minor principal stress, minor principal stress divided by 2. Major principal stress minus minor principal stress divided by 2. Now we will put values here or formulas for major principal stress and minor principal stress. Therefore, tau max, which is equal to, therefore tau max, which is equal to sigma 1 minus sigma 2 divided by 2. Okay, so therefore tau max, which is equal to, now you tell me the formula for sigma 1. Okay, first we will take this 1 by 2 as a common and then we will write formula for sigma 1 and sigma 2. So formula for sigma 1 is 16 divided by pi d cube in bracket m plus square root of m square plus t square. Okay, this is the formula for finding out major principal stress. Then minus. Okay, and then we will write formula for minor principal stress. Same formula, 16 pi d cube in bracket m, instead of this plus we will write here minus, minus square root of m square plus t square. Okay, and this is whole bracket close. Now we will take this 16 pi d cube as a common. 16 pi d cube as a common. So therefore tau max, which is equal to, tau max, which is equal to 16 divided by 2 pi d cube. 16 divided by 2 pi d cube. Now we will see which parameters remaining in this bracket. So this m plus square root of m square plus t square. So m plus square root of m square plus t square. This is remaining minus in bracket. Already this 16 pi d cube we have taken common. So here m minus square root of m square plus t square. That much remaining in this bracket. Now, therefore, tau max, which is equal to, tau max, which is equal to 16 divided by 2 pi d cube. Now we will see here. This m plus square root of m square plus t square we will take as it is. Due to this negative sign, the sign of values in bracket will be changed. So minus m, this minus minus gets plus. So plus square root of m square plus t square. Now this plus m and this minus m gets cancelled. Okay. Now square root of m square plus t square plus square root of m square plus t square. Therefore, tau max, which is equal to 16 2 pi d cube in bracket. One time m square plus t square plus second time 1. So 1 plus 1, that is 2 square root of m square plus t square. Okay, that is remaining. So this 2 and 2 gets cancelled. Therefore, tau max, which is equal to what is remaining? 16 divided by pi d cube in bracket square root of m square plus t square. That is the formula for finding out maximum shear stress. This is the formula for finding out maximum shear stress. You have understood, or anybody having any doubt? Yes. If no doubt, please write down. Okay, let me know after your writing is over. So we will take next point. Over.
No, ma'am.
Okay, let me know after your writing is over.
Over, ma'am.
Okay. So now we have derived or we have studied and formulas for finding out principal stresses and maximum shear stress for solid circular shaft. Now we will see both formulas for hollow circular shaft. Okay, so please write down next point. For hollow circular shaft, for hollow circular shaft, for hollow circular shaft. Okay. So for this hollow circular shaft, we have to find out major principal stress, minor principal stress, maximum shear stress, and their planes. Okay. So before writing this formula, I will explain some theory. Already we have studied it, how to find out major principal stress for solid shaft. Okay, for solid shaft. And before that, we have derived two formulas. Okay, before that, we have derived two formulas. Normal stress, which is equal to 32 m divided by pi d cube. Okay, 32 m divided by pi d cube, and shear stress, which is equal to 16 t divided by pi d cube. Okay, both these formulas are derived from this bending equation, sigma b, which is equal to m into y upon I. Now we will see for hollow shaft. Okay, suppose this is inner diameter and this is outer diameter of circular shaft. Okay, so inner diameter suppose denoted by di and outer diameter is denoted by do or d naught. Okay, so whenever we will take this y nothing but the location of stress or maximum stress from CG to outermost fiber. Okay, CG to outermost fiber. Now you tell me which value we will consider that is outermost fiber, di or d naught. Original formula, that is y, which is equal to, suppose we have taken solid circular shaft. Okay, this is CG, and from this to extreme fiber. So this is suppose total diameter d. So y, which is equal to d by 2. But for this particular case, okay, internal diameter is there and external diameter also there, and y nothing but the location of stress. That means from CG to extreme fiber of member, So here y, which is equal to d naught divided by 2. Okay, got it? Y, which is equal to d naught by 2. Now we will move towards this moment of inertia. So I, which is equal to moment of inertia for circular section, you know that pi by 64 d raised to 4. But this is for solid shaft. Now for this hollow shaft, pi by 64 d outer raised to 4 minus d inner raised to 4. So this is the moment of inertia. Now we will put values here. So sigma b, which is equal to m, we will take as it is, divided by I. I is pi by 64 d naught raised to 4 minus di raised to 4 into y. Already we have calculated y, d naught divided by 2. Now we will rearrange this. Sigma b, which is equal to 2m, sorry, 2 1s are 2, 2 3s are 6, and 2 2s are 4. So this 2 is not here. Okay, so what is remaining in denominator? M into d naught. M into d naught divided by pi by 32 d naught raised to 4 minus di raised to 4. Now this 32 shifts numerator. So sigma b or normal stress, which is equal to 32m into d outer divided by pi in bracket d outer raised to 4 minus d inner raised to 4. So this is the normal stress for hollow circular shaft. Okay, and you observe here for solid circular shaft 32 m is there. Okay, 32 m is there. Okay, and here pi d cube. But in this particular case, here d and raised to 4. So one d gets cancelled and here remaining d cube. But here d naught and d naught raised to 4 minus di raised to 4. That's why here 32m into d naught divided by pi in bracket d naught raised to 4 minus di raised to 4. Okay, so this is the normal stress. Now you tell me for shear stress, how it comes? 16 as it is, t again as it is, into d naught divided by pi d naught raised to 4 minus di raised to 4 as it is. Okay, got it? So these are the normal and shear stresses. Now we have to put these values in major principal stress, for major principal stress formula and minor stress formula. So by using this basic normal stress and shear stress, we have to find out principal stresses. So we will write down directly formulas. Okay. Because of in your examination, no derivation will be asked. So we will write direct formulas. Okay. So for hollow circular shaft, for hollow circular shaft, for hollow circular shaft. First we will write down major principal stress. Okay. First major principal major principal stress, major principal stress, which is equal to or sigma 1, major principal stress sigma 1, which is equal to, so formula for this 16 d naught divided by pi d naught raised to 4 minus di raised to 4, okay, into in bracket m plus square root of m square plus t square. So this is the equation for finding out major principal stress. Now we will write for minor principal stress. Now you tell me at which point this formula will change for minor principal stress. Minor principal stress. Only one change is there na, in major principal stress and minor principal stress. So anyone please? This is 16 d naught divided by pi d naught raised to 4 minus di raised to 4 in bracket m here in yes
minus.
instead of this plus we will take minus square root of m square plus t square. So this is the formula for minor principal stress. Now we will see for maximum shear stress. So maximum shear stress, maximum shear stress, that is tau max, which is equal to tau max, which is equal to 16 d naught divided by pi d naught raised to 4 minus di raised to 4 in bracket square root of m square plus t square. Okay, so this is the formula for maximum shear stress, and for principal stress, that is tan 2 theta, which is equal to t divided by m. So these are the formulas for hollow circular shaft. So please write down, then we will solve numericals on all formulas. So let me know after your writing is over.
Okay,
Okay, so now we will take numericals. So please write down problem number 1. A solid shaft of diameter, a solid shaft of diameter, shaft of diameter 80 mm, diameter 80 mm, is subjected to 80 mm is subjected to a twisting moment, a twisting moment of 8 mm, that is millinewton mm, and bending moment of bending moment of 5 mm 5 mm mm at a point, at a point, at a point, full stop. Determine, determine, determine first number principal stresses, principal stresses, principal stresses, and second, position of the plane on which they act. Position of the plane, position of the plane on which, position of the plane on which they act, on which they act, full stop. So this is the problem. Now we will solve. So solution. So first step, we will write which parameters are given and then we will solve problem. Okay. So your problem writing is over. Okay. First you understand, then I will give time for writing. Okay. So first we will write which parameters are given. So I will read problem. A solid shaft of diameter. So diameter is given. So first parameter is diameter is given. So D, which is equal to 80 mm. After that, next is subjected to a twisting moment, that is T, twisting moment, T, which is equal to 5 mm. So 5 millinewton. So we will convert into Newton. 5 into 10 raised to 6 Newton mm. Newton mm. After that, and bending moment of 5 mm. So bending moment means M is given. So M, which is equal to, sorry,
Twisting
yes,
movement 8 mm.
yes, twisting moment is 8 mm. So I will correct this. So twisting moment is 8 mm. So here 8 into 10 raised to 6. And bending moment is 5 mm. Here again conversion is there. So M, which is equal to 5 into 10 raised to 6 Newton mm. So that much parameters are given. Now second we will write what you have to find out. Okay, you read problem and tell me to find out. To find. So in that, first, what you have to find out? Sigma 1, which is equal to question mark, sigma 2, which is equal to question mark, theta 1 and theta 2, which is equal to question mark. So that much parameters we have to find out. Okay. Now we will solve step by step. So first we will find out major principal stress. So our step number 3, to find, step 3, to find major principal stress, major principal stress. So major principal stress is denoted by sigma 1. So sigma 1, which is equal to, which formula is applicable for finding out sigma 1? Sigma 1, which is equal to 16 divided by pi d cube in bracket m plus square root of m square plus t square. Okay, so all parameters are given. Just you have to put values here. So sigma 1, which is equal to 16 divided by pi into diameter is given 80. So 80 cube in bracket. M is given. So M 5 into 10 raised to 6 plus square root of. Okay. So here into 10 raised to 6, 10 raised to 6. We will take here common. 16 into here 10 raised to 6 we will take as a common, because of in bracket you have to not do more confusions. So M, what is remaining here? M is 5 plus square root of 5 square plus 8 square. Okay. So you solve this and tell me what is the answer. Therefore, sigma 1 which is equal to
143.57 Newton per mm square.
okay, good. 143.57 Newton per mm square. So this is the major principal stress. Now we have to find out minor principal stress. Okay, next step is to find minor principal stress. To find minor principal stress. Minor principal stress. Minor principal stress. In major and minor principal stress, only here sign will be changed. Okay, so minor principal stress sigma 2 which is equal to 16 pi d cube in bracket m minus square root of m square plus t square. That what change is there. Therefore, sigma 2 which is equal to 16 into, we will take 10 raised to 6 common, divided by pi into 80 cube in bracket m is 5 minus square root of 5 square plus 8 square. Therefore, sigma 2 which is equal to
44.1 Newton per mm square tensile.
plus or minus
Tensile mm plus 1.
plus 44.09.
Yes, ma'am.
Okay, so 44.09 Newton per mm square. So this is the minor principal stress. Once we got major principal stress and minor principal stress, next target is you have to find out principal planes. And already you know that how to find out principal plane. Which formula is applicable for finding out principal plane?
Tan 2 theta is equal to T upon M.
So step number 5, find principal plane. Principal plane. Find principal plane. So tan 2 theta, tan 2 theta, tan 2 theta, which is equal to T divided by M. Okay. So here we will put value tan 2 theta, which is equal to T is 8 into 10 raised to 6 divided by 5 into 10 raised to 6. This 10 raised to 6, 10 raised to 6 gets cancelled. Therefore, theta which is equal to tan inverse of 8 divided by 5 divided by 2. Therefore, theta 1 which is equal to how much?
28 degree.
28 point something or exactly 20?
59.84.
No, 59. No. Divided by 2 is remaining. So 28 is correct answer, but 28 exactly not. 28 point something. Yes, how much? 28 point?
20.99.
Yes, 28.99 degree. This is the major principal plane. That is theta 1. Major principal plane. Major principal plane. Then next, theta 2. Now you tell me how to find out theta 2. So theta 2 which is equal to theta 1 plus 90 degree. So which is equal to 28.99 degree plus 90 degree. Therefore, theta 2 which is equal to
118.
118.99 degree. And this is the minor principal plane. This is minor principal plane. Minor principal plane. Okay. Understood? Anybody having any doubt in any step? If you have doubt, please ask me. I will clear. Otherwise, please write down. Okay, let me know after your writing is over. I will give time for writing.
Okay.
Please write down next problem. A solid circular shaft. A solid circular shaft. Solid circular shaft. Solid circular shaft of diameter 120 mm. Of diameter of diameter 120 mm. 120 mm. Carries bending moment and carries bending moment and twisting moment of of magnitudes of magnitudes 35 kilonewton meter 35 kilonewton meter and 25 kilonewton meter 25 kilonewton meter respectively. Full stop. Find the major principal stress. Find the major principal stress. Find the major principal stress. Major principal stress induced in the section. Induced in the section. And does it develop? Does it develop? Does it develop? So here only you have to find out major principal stress and major principal plane. That much we have to find out. So we will solve problem. So step number 1, given. So you read problem and tell me which parameters are given.
T and M.
Tm as well as diameter. So d which is equal to 120 mm. D which is equal to 120 mm. Next, twisting moment, that is T, and bending moment, that is B. First here bending moment and then twisting moment. So we will write here also. First we will write bending moment, that is M, which is equal to how much?
35.
35 kilonewton meter. So we will convert into Newton mm. Now you tell me how to convert in this kilonewton meter to Newton mm. So M, which is equal to kilonewton to Newton 10 raised to 3 into meter to mm 10 raised to 3. So 3 plus 3, that is 6. So 35 into 10 raised to 6 Newton mm. This is the M, value of M. Then T, twisting moment is given. Twisting moment is 25 kilonewton meter. Again, you have to convert this kilonewton meter to Newton mm. So T, which is equal to 25 into 10 raised to 6 Newton mm. So this 10 raised to 6, how comes? So kilonewton to Newton. Whenever you have to convert this kilonewton to Newton, at that time 10 raised to 3. And meter to mm 10 raised to 3. So this 3 plus 3, that is 6. So T, which is equal to 25 into 10 raised to 6 Newton mm. Then step number 2, find. So here only 2 terms you have to find out. First one is sigma 1, which is equal to question mark, and theta 1, which is equal to question mark. That much you have to find out. So we will write here. Then next step number 3. So step 3 is find major principal stress. Major principal stress. find major principal stress. Major principal stress sigma 1. So sigma 1 which is equal to, how to find out? Sigma 1 which is equal to 16 divided by pi d cube in bracket m plus square root of m square plus t square. So all parameters are given, just you have to put values here. Therefore sigma 1 which is equal to 16 divided by pi into d 120 cube into in bracket. So we will take this 10 raised to 6 common. So into 10 raised to 6, and here value of m is 35 plus square root of 35 square plus 25 square. So you solve and give me answer sigma 1 which is equal to how much? Yes, how much? पूजा, स्नेहल, सायली, ऋतुजा, आशिष अटकळे, रोहन चव्हाण, युवराज, सनी कचरे, विवेक काळे. Please give me answer. Sigma 1 which is equal to how much?
मॅडम किलो न्यूटन म्हटल्यावरनं 10⁻³ पाहिजे होतं ना?
Yes. देखो 35 kilo Newton. Okay. So kilo Newton to Newton 10 raised to 3. And here meter आहे ना अगेन. मोमेंट कशात मेजर करतो आपण? किलो न्यूटन मीटर मध्ये. तर आपलं डायमीटर mm मध्ये आहे. बरोबर आहे. तर आपल्याला मोमेंट पण काय करायला लागेल? न्यूटन mm मध्ये कन्वर्ट करून घ्यायला लागेल. मग किलो न्यूटन टू न्यूटन असेल त्यावेळी 10 raised to 3. आणि मीटर टू mm करताना किती घेतो आपण? 10 raised to 3. सो दिस 3 plus 3 that is 6. त्यामुळे इथे 10 raised to 6 आलेलं. आलं का लक्षात आता?
होय.
So now please calculate and give the answer. Sigma 1 which is equal to how much?
Two to 9.92.
Okay, good. Correct answer. 229.92 Newton per mm square. Okay. So for your understanding, you calculate minor principal stress and give me the answer of minor principal stress. Okay. So here only you make change 35 minus square root of 35 square plus 25 square and give me answer. Sigma 2 which is equal to how much? In this problem, not asked, but for your understanding. Sigma 2 which is equal to how much? How much? Yes.
Minus 1842.06.
1
1842.06.
Anyone having another answer?
Minus.
Minus, but I think value not correct. Please check once again. Other students, please calculate and give me answer.
Minus 23.61.
Yes, correct answer. So sigma 2, which is equal to minus 23.61. But here only major principal stress have asked. So major principal stress sigma 1, which is equal to 229.92 Newton per mm square. And then last answer, that is you have to find out major principal plane. Okay. So how to find out major principal plane? Find major principal plane. Find major principal plane. Major principal plane. So major principal plane, that is tan 2 theta, which is equal to t divided by m, right? So theta, which is equal to tan inverse of t. T is how much? 25 divided by 35 and divided by 2. Therefore, theta, which is equal to, yes, theta, which is equal to how much?
17.776.
17. Okay, correct answer. 17.76 degree. So this is the major principal plane. Okay. Please write down fast. We will take next problem. And here how to find out theta 2? So theta 2, which is equal to theta 1 plus 90 degree. So 17.76 plus 90. Therefore, theta 2, which is equal to
107.76.
107.76 degree. This is not as asked, but for your understanding, I have calculated. This is minor principal plane, and this theta 1 is major principal plane. Major principal plane. So please write down fast. We will take next problem.
Oh, hi.
Okay, please write down next problem. A maximum allowable shear stress. A maximum allowable shear stress maximum allowable shear stress in a hollow shaft, in a hollow shaft, hollow shaft of of external diameter, external diameter equal to external diameter equal to twice of internal diameter, twice of internal, twice of internal diameter is 80 Newton per mm square, 80 Newton per mm square, full stop. Determine, determine, determine the diameter of the shaft, determine the diameter of the shaft, diameter of the shaft, diameter of the shaft if it subjected to, if it subjected to, if it subjected to a torque of, a torque of, subjected to a torque of, torque of 4 into 10 raised to 6 Newton mm, 4 into 10 raised to 6 Newton mm, and bending moment of, bending moment of, bending moment of, bending moment of 3 into 10 raised to 6 Newton mm. So in this problem, maximum shear stress value is given, torque is given, and movement is given. So we have to find out diameter. Okay. So first we will write which parameters are given, and after that we will see how to find. So step number 1, given parameters. So here first given, that is tau max. So tau max, which is equal to 80 Newton per mm square. After that, here one sentence is given. External diameter equal to twice of internal diameter. So from that, D naught, which is equal to 2 times diameter of internal. Okay. After that, twisting moment is given. So T, which is equal to 4 into 10 raised to 6 Newton mm, and bending moment M, which is equal to 3 into 10 raised to 6 Newton mm. The next step is to find. So which parameters you have to find out? Diameter of shaft. So external diameter, which is equal to question mark, and internal diameter, which is equal to question mark. Okay. So now we will see step by step how to find out external and internal diameters. So you observe here maximum shear stress value is given. So from this maximum shear stress value, we will find out the diameter. So first we will apply here tau max formula. Therefore, tau max, which is equal to, what is the formula for finding out maximum shear stress? 16 D naught divided by pi into D naught raised to 4 minus Di raised to 4 into in bracket m square plus t square. Okay. Now we will put value here. The value of tau max is given. So we will put here 80, which is equal to 16 into the value of d naught is how much? Value of d naught 2
2
times,
di.
2 times the diameter of inner circle. So 16 into 2 di, 2 di, okay, divided by pi in bracket. D naught means 2 di raised to 4 minus di raised to 4. Okay. Now into in bracket here square root of m square t square. So the value of m is 4 into 10 raised to 6. Sorry, 3 into 10 raised to 6. And the value of t is 4 into 10 raised to 6. So from that we will take 10 raised to 6 as a common. Okay. So here we will take common into 10 raised to 6. So what is remaining in bracket? 4 square plus 3 square, right? 4 square plus 3 square. So 80, which is equal to 16 into 2. How much? 32. Okay, 32 di into 10 raised to 6 divided by pi we will take as it is. So 2 raised to 4. How much? 2 raised to 4 is
16.
16 minus 1. 1 raised to 4, that is 1. 16 minus 1 is 15 di raised to 4. Got it? Here I will explain once again. 2 raised to 4 di. So 2 raised to 4, that is 16 di minus 1 raised to 4, that is 1. So 16 minus 1 means 15 di raised to 4. Okay, 15 di raised to 4 into 15 di raised to 4 into. Now here square root of 4 square plus 3 square. So square of 4 is 16 and square of 3 is 9. 16 plus 9 is 25. And when we will take the square root of 25 is 5. Got it? Now this di and 1 di gets cancelled. So what is remaining? 80, which is equal to 32 into 10 raised to 6 into 5 divided by pi into 15 di. Now we will shift this di to left side and this 80 to right side. Therefore, di, which is equal to 32 into 10 raised to 6 into 5 divided by pi into 15 into 80. Now you calculate and give me answer di, which is equal to how much?
di cube राहणार ना मॅडम.
Yes, di cube. So di cube, which is equal to 32 into 10 raised to 6 into 5 divided by pi into 15 into 80. Yes, how much? Di, which is equal to, therefore di, which is equal to. Okay, you do this calculation first and after that you take third root of answer. You will get answer.
$34.87.
Okay, good, correct answer. 34.87 mm. 34.87 mm. So this is the internal diameter. We have to find out both diameters. Therefore, external diameter d naught, which is equal to 2 into di. Now we will put value here. So 2 into 34.87. Therefore, external diameter which is equal to
69.74.
okay 69.74 mm. Got it? If anybody having any doubt in any step, please ask me. I will clear. Otherwise, please write down fast. Okay, over.
No, ma'am.
Okay, let me know.
Uh-huh.
Okay, so today we will stop here. Next problems we will see in next lecture.